Hello everyone, welcome back to my channel. In this video, I am going to talk about what is mean by actions and transformations in the PySpark. But before that, we need to understand some basics of Spark data processing and some internal details. Okay, so let's get started. In the last videos or in the last few videos, I would say, we have learned how we can create a data frame, okay, by reading a file or by creating it or own. Now, in an interview, they will ask you what is meant by the distributed data structure, or they will ask you why data frames are called as a distributed data structure, right? So the only reason why this data frame will be called distributed data structure is because it's it's composed of bunch of partitions. Okay, bunch of partitions. That's the reason it is called as distributed data structure. And we know, right, how the data got partitioned in multiple partitions. There could be two ways to partition the data. Either you tell you have to specify to the Spark that I want three partitions. Okay. So it can be handled from the user side, or it can be handled from the Spark side itself, based on the data, based on the type of data, or based on the size of data. They create the partition. And that's why any data frame generally called as distributed data structure. I hope it is clear now. Now, the next thing is what Spark bring to us, right? As a data engineer, we worked on the data frame, right? So what Spark does for us is it hides all the complexities of data processing behind the scene, and it will simply allow you to work with the data frame. Okay. Now, when you start reading this data, right, because for you it's a data frame, when you start reading this data frame, right, you start doing some computations, right? Some kind of you start performing some kind of operations on top of it, correct? Let's say, let's take an example. Let's say this is your df and you say df dot filter. They will ask you this question, okay? And when you are doing this df dot filter, you are getting a new data frame. So sometimes they ask us why we are keep changing the data frames, right? Because we are making the changes in the data frame. That's how they will ask you. But always remember, no one will be able to change the data frame. You cannot change the data frame because data frames are immutable. Data frames are immutable. Okay, you cannot change it. The meaning of this line is when you are doing a filter, you are actually getting a new data frame. Even if you perform multiple operations after this, right? End of the day, you will be receiving a new data frame. And if you try to simply display it without storing into a new data frame, that will be called as a temporary data frame internally, right? Which will not result a physical data frame for you, right? So you cannot change this data frame, but you can perform some operations on it to see what will be the behavior of this data frame before storing into a new data frame. Okay. So whenever we do some perform some operations, or I can say whenever we use some functions on top of data frame, it will generate or create a new data frame. That's why the data frames are immutable data structure. Okay, always remember it. Now we'll talk about how we perform operations on the data frame, right? Obviously, in Spark we have methods to perform some operations in the data frame. Now these methods are basically divided into two categories. Okay, so the first one is known as transformation. Okay, and the second is known as actions. Okay, again this transformation is divided into two categories. One is narrow transformation and one is wide transformations. We'll not go into this detail in this particular video. We will just talk about what is transformation, what is actions, how they both are different, okay, and how exactly they work behind the scene. Okay, now let's talk about transformation first. Let me scroll down. Yes. So when we talk about transformations, it's a kind of a operation, right? Which will result a new data frame to you. Okay. Now let's talk about few examples. We'll do everything practically as well, right? But let's try to understand or digest the concept, right? So when I say transformations, right, I have multiple functions given by the Spark which actually work as a transformation. For example, filter. For example, union. For example, map. For example, select. For example, um, like let's say group by, joins, order by. So there are multiple functions, right? These functions are known as transformations. Okay, why they call transformation? We'll quickly look into it. Now, similarly, we have different type of functions which are segregated as an action, like collect, show, count, first, take. I'm just giving a few examples, right? But there are many more. Okay, there are many more. Now you will think, do I have to remember all each and every one? No, you don't have to remember like which function is action and which function is transformation. But if you know it, it's better, right? And I'll tell you, you cannot just remember it, right? When you start working on these functions, right, slowly and gradually you are kind of used to these functions, and you know, right, after some time, that these are all transformations and these are all actions. But how internally they both are different, right? Why I'm saying this is, these functions are known as transformation, these functions are known as actions, right? Because at the end of the day they both are methods, right? So when we say transformation, it means, okay, it means whenever we do some operation, right, on a data frame, okay, the operation will not be performed immediately. Okay, it means the actual execution will not take place. It will simply create a lineage. Okay, so let's say lineage means life cycle of a data frame based on your actions, you can say. So let's say this is your data frame. You did one, you use one function filter. So even though you used it, right, it's actually not executing it. It's just creating a lineage. Okay, after filter, the user want to select some particular columns. Then user want to group by based on some columns. Then user want to join some columns, right? But till now, the actual execution has not been done. So the point to be noted here is that when you apply any transformation on the data frame, it will not perform the operation immediately, but it will create this kind of a lineage. Okay, and this lineage in the PySpark is known as DAG. The full form of DAG is directed acyclic graph. Okay, now when the actual execution happen, that is the question now, right? So as soon as you perform some actions in this data frame, the actual execution will take place, right? So it means these transformations has to wait, right, to perform the actual execution, to being a part of the actual execution, I can say, right? Correct. That's why they are called, that's why in the Spark we call transformations are lazy evaluations. Okay, so if someone asks you what is mean by the lazy evaluation in the PySpark, transformations are lazy evaluation in the PySpark, right? Because l- they will be used later. I mean, when you perform an action, correct? At that time they will start evaluating it. As of now, they are just creating a lineage. They are creating a DAG in Spark form. Okay? When the actions comes into the picture, they will actually start doing the transformation. Now, you must be thinking, what is the use? Why we are waiting till last? We can perform right away, right? What is the problem in it? Right? So always start asking questions from yourself, right? Why we did it, right? Obviously there will be a reason, right? So why Spark does it? Why Spark wants this lazy evaluation to be a part of your execution flow, right? Because of several benefits. What benefits? It will give you, or it will do some optimization on top of your operations. Let's say you wanted to do join, right? Now, if you wanted to do join on table 1 and table 2, right? It will present you some rows or some table. Now, when I say if I put filter on top of one of the table and then try to do join, obviously the execution speed will be less, right? So what Spark will do is based on your functions, right? It will think what all functions he can push down, right? At the very beginning, which will result the next execution to be faster, right? So internally, it will analyze all these functions and it will try to do some optimization techniques like predicate push down, like pipelining and all, right? Which will also helps to facilitate fault tolerance, right, for the Spark. So that is the reason that transformations are lazy evaluations. Okay, so I hope it is clear now why transformations are lazy evaluation and what is mean by the actions. Now, why we need action? Obviously, at some point of time you want the actual data, right, or the cleansed data or the data which you wanted to work upon. Okay, and that's what actions does. So actions methods are you can say action methods are to access the actual data available on the data frame. Okay, and lazy evaluation, I hope it is clear now, right? So based on the DAG sequence, it will start performing the operation. It will do all necessary optimizations into the execution plan, and then it actually execute your data set. Okay, so let's go through the questions. What is the benefit of immutability? Again, since we created the lineage, right? If any operation goes down, goes incorrect, right? Your initial data frame will be saved. That is the reason of immutability. It will always hold the actual value of data frame. Okay. Now, what are transformations? What are their use? We already discussed type of transformations. Okay, we will just cover the type of transformations. So there are two type of transformations actually. One is, oh, I already discussed, right? Narrow and wide, right? We'll talk about this later, but in this particular video, we'll just focus on actions and transformation. So let me quickly switch over to my Spark uh, basically Databricks workspace, and then I'll show you the execution flows. Okay, we'll see how it actually works. So the first cell, I have imported the libraries. In the second cell, I'm creating a data frame. Oh, I hope the cluster is up. Yeah, it is up. So in the second, again, in the second cell, we are creating a data frame. In the third cell, I'm doing one operation right here, and this operation is will be known as transformation, right? It will result me a data frame, but it's not actually executed. Okay, so I'll do again. You see, there is no task, no stages, right? No jobs. Nothing has been triggered till now from the driver side. It just the lineage is created internally. Then to see if actually lineage is there or not, let's do some more operations. Okay, let's say I'll do some group by df dot, then use one of the column, let's say name, and you can do, let's say, count on number underscore 1, and then this will also result one new data frame. Okay, now the so there are two ways by which you can check your DAG or the lineage, right? Either you can simply run this with the help of actions, or if you wanted to see without running it even, right, there is a method which will help you with that operation to at least check what will be the physical plan of this job. Okay, so if you run, oh my bad, I didn't run anything before it. Let me run all these things till here. I did some mistake, I think, here. So group by name, then dot count. What it says? Okay, I am not sure if it is not able to take it up, but let's use it. Okay, count, and then it should work. Let's do like that. Okay, let's say I wanted to know the count based on this group by, and then I wanted to know the physical plan of it. So this is the function which you can use. Explain, these have different modes, but I like this formatted mode a lot. There are 5 different modes. We'll talk about in some other video, but here there are 5 different modes by which you can see. So you see, these are all operations, physical plan. So first of all, it will scan the CSV, then it will perform some filter, then select, then aggregate, group by, right, and then exchange happen, because every group by will perform some shuffle. We'll talk about this shuffle also. Okay, but you see this plan, right? This kind of lineage will be created by Spark. Okay, which you can directly see from here. If you don't want to what to say, if you don't want to run the program directly, this will help you to create the physical plan. But if you wanted to perform some actions on top of it and then you wanted to see it, you can do that one also. So let's say this is the data frame and I wanted to perform some actions on it. So df dot show, because I wanted to see the result. So I did one action, and if you see now, it started the job. Till now it didn't started the job. It means the actual execution was not taken by Spark till now. But as soon as I invoked one action, the actual execution comes into the picture. And this is the result, right? So this is how you can segregate what is actions and what is transformation. Now, if you see, this is the result and this is the job. You can go to any of these jobs and I'll show you the DAG also. And this is your DAG. Scanning CSV, then doing an exchange because of the group by. We will talk about why this exchange happened. We'll talk each and everything, right? What is wooden state code generation, whole stage code generation, what is exchange, why this exchange happened, right? We'll go in this deep, don't worry. But as of now, you must have understood, right, what is transformation and what is action. So actions comes into picture when you want actual execution to take place. Transformations are actually means by some operations which you want to be done on your data frame, right, to get a overall to get the desired result from the data frame. Okay, so I think that's all for this video. I hope this video will be helpful for you guys. Thank you. Thanks for watching this video. Bye.